Now let's see the LCM of these three numbers. Okay, HCF and LCM of these three numbers. One is 14, 56, 81. Now, in order to find out the HCF, I am using both of them, HCF and LCM. I am first using the prime factorization method. So this method says that express every number as product of prime factors. If you take 14, 14 can be expressed as 2 into 7, right? And 56 can be expressed as 8 into 7, that is by 2 power 3 into 7, so prime factors. And 81 can be expressed as 3 power 4, right? Now if you see this, we have 2 and 7 here, and we have 2 and 7 here, and we have 3 here, right? So overall, what are the prime factors we have written it in? One is 2 in terms of 2, in terms of 3, and in terms of 7. So see that all the numbers will have all these prime factors. Even if they are not present, write them as power 0, which means, see this, 3 power 0 is not present here, better have it. So as 3 power 0 and 3 power 0 is here, and 2 and 7 are not present here, that is why I am writing it as 2 power 0 and 7 power 0. Now, in order to find out the HCF, see, whenever it is HCF, which means highest, or GCD, which means greatest, we are going to take the least powers. That is how you can remember it, right? Whenever you are taking about HCF, I am just telling you a shortcut to remember it. Whenever the term is highest, you take the least one. So least index means among these 2's, what is the least index? 2 power 0. Now among these 3's, what is the least index? 3 power 0. Among these 7's, what is the least index? 7 power 0, right? See, if you would have not written this, 7, 3 and 2, you would have missed it out, right? So what is it? That is why it is getting it as 1. Now the same way on the other side, when you are trying to find out the least LCM, least common multiple, now whenever you have least, you take the highest powers. Now in this 3, what is the highest power for 2? See, 2 power 3, that is why I am taking 2 power 3. And in this 3, what is the highest power? 3 power 4, that is why I am taking 3 power 4. And in these 3, what is the highest power for 7? 7 power 1, that is why I am taking 7 power 1. So what is it? Now if multiply them, you are going to get this one. So this is the LCM and that is the HCF. And the other one is, you can find out the HCF using the division method as well. So in this division method, since 3 numbers are given, you can take any 2 initially and find out the HCF. And once you get the HCF, take the third one and find out the HCF between the HCF of the initial 2 numbers and the third number. So here I will take 56 and 81 since they are greatest. So always start with the greatest one, greatest and the second great. So if you take these 2, then you are going to get, see, I am just dividing them. So divide it. Now this is going to be the remainder, which will become the new divisor for the second time. Now this will be the divisor and this will be, you have to divide this one, right? 56. And now the remainder is 6. Therefore 6 was the remainder, now it will become the divisor, and again you are going to take this and you are going to divide it. Okay, likewise if you keep going, you will see that for these 2 numbers, the GCD is 1. So whenever you have such a pair of numbers with GCD as 1, you can call them as co-prime numbers. Co-prime means both of them will not have any common divisor other than 1, right? So that is why here the GCD is 1. Got it? Okay, now you take 1 and 14 and find out the greatest common divisor. For 1, always 1 is the divisor, and 14 also 1 is the divisor. Therefore you can say that 1 is the only divisor. I am just writing it here, not required. But still what I wanted to show you is, we have taken a pair of numbers and we found out the GCD, and with that GCD we have taken the other number and we found out the GCD of that. So finally 1 is the GCD. Okay. Next one, again we can do the same thing over here as well. So we have taken 3 numbers, and for these 3 numbers we have to find out HCF and LCM. So for let's see the prime factorization method first. So 108 can be written as 4 into 27, right? So it is going to be 2 power 2 into 3 power 3, and 288 can be written as 2 power 5 into 3 power 2, right? So 32 into 9, and 360 can be written as 2 power 2 into 3 power 2 into 5. Now if you see this, the total prime numbers used in this three numbers is one is 2, other is 3, other is 5. So if they are missing, just write them as a power of 0. So here I am going to write it as 5 power 0, 5 power 0 because 5s are missing here, right? Now when you are trying to find out the HCF or GCD, you have to go with the least power index. Now what is the least power index here? 5, in this 5 power 0, and in this 3 power 2, and in this 2 power 2, right? Therefore 2 power 2 into 3 power 2 into 5 power 0, that is why we got 63. Now in the other side, when you are trying to find out the LCM, since I asked you to remember it this way, LCM is least, therefore you take the highest powers here. So what is the highest power here? So 2 power 5 is the highest power, so we are taking it. And coming to 3 power 3 is the highest power, I am taking it. And coming to 5, the highest power is 5 power 1, that is why I am taking it. And this is the answer. Okay. And next one is division method. So if you take division method, so take two numbers, better take two highest numbers. So what are the highest numbers here? 288 and 360. Now you keep dividing them, right? So if you divide this one, I got the initial remainder as this. Now this remainder will become the new divisor, and you have to divide the old divisor. So the old divisor is going to be now divided. So again I got a remainder of 0 here. So whenever you get a remainder of 0, then you can say that 72 is the GCD of these two numbers. Got it? So for these two numbers, I got that the 72 is GCD, right? Now I'll take this one and this one, 72 and 108, and find out the GCD. Now when I did that, so I found out that 36 is the GCD. Therefore 36 will become the GCD for all the three put together. Okay? And on the other side, we can apply the same division method. So here I think we have to see the division method for LCM as well. So when I take 2, here also I think I missed it out. Okay, when I take 2, why am I dividing with 2? Because at least two of them are having 2 as the common factor. So whenever you see any two of them having a common factor, you can divide those two and leave the remaining one. So see this 2, when I am dividing 14, then I get a quotient of 7, not the remainder. Quotient is 7, so write the quotient as 7. And for 56, 28, right? And since these two are evenly divisible, I am dividing them, and since this is going to give me a remainder, I will not divide it, I will just leave it as it is, right? Now whether to go it for one more time or not, that depends on whether any two of them are going to have a common factor other than 1. Now if you see 7 and 28, there is a common factor 7, right? Therefore I can go with one more time division, right? So again I am writing it, and since 81 is not divisible by 7, I just leave it as it is. Now if you see this, for any two of them or all of them, there is no GCD other than 1. Therefore I am leaving it there. So product of all this is going to give you the LCM. Now the same method can be applied here, right? If you see them, all of them are even numbers, so definitely 2 must be a common divisor. So I'll take 2 and I'll write all the quotients here. These are all quotients because it is divisible. Again, all are even numbers, I'll take 2, I'll write the quotients, right? Now I found out that all 3 are divisible by 3. Therefore I'm again dividing with 3 and I'm writing the quotients here. And again I found out that all 3 are divisible by 3. Therefore I'm dividing them. And here I see that only 2 of them are divisible by 2. Therefore leave 3 as it is and divide those two and write the quotients there, right? So I got 4 and 5. Now if you see them, no two of them will be having any common divisor. Got it? That is why you leave it here and you multiply all of them, then you are going to get this. Now if you see this one and this one both will be same, right? So anyway the answer should be same. Got it? Either you use that method or this method, division method or prime factorization method, you are going to get the same answer. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay, IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.